Hi students and friends, this is your host and teacher Sayyid Ayazuddin Haider and you're watching Learn and Teach by Sir Ayaz. So I was doing the paper 42 for 0620 and it's of May-June 2023. I'm done till question number 3. So let's continue from question number 4. Here's question number 4. Solid sodium hydroxide is a base which dissolves to form an aqueous solution, NaOH aqueous. A. State what is meant by the term base. They are proton acceptors. B. State the term given to a base which dissolves to form an aqueous solution. They are metal hydroxides. Technically, they are known as alkali. C. State the color of thermophthalein in NaOH aqueous. NaOH aqueous is alkali, so it must be blue. In alkali, it shows blue color. It gives blue color. D. Complete the word equation for the reaction of NaOH aqueous with ammonium chloride. Ammonium chloride is ammonium salt. So whenever you react ammonium salt with alkali, here sodium hydroxide is alkali, what you will get? You will get 3 products. You will get ammonia, water, here I will write ammonia, water, and the salt. Salt obtained must be formed between sodium and chloride. So we will write sodium chloride. E. Some metal oxides react with NaOH aqueous. Metal oxides mean they are bases. Number 1, state the term given to a metal oxides which react with bases such as NaOH aqueous. Now there are some oxides which react with both acidic oxides, that's non-metal oxides, and metal oxides. They are known as amphoteric oxides. So I will write amphoteric oxide here. Number 2, name a metal oxide which reacts with NaOH aqueous. You have 2 oxides in your syllabus which act as amphoteric oxide. This is aluminum oxide or zinc oxide. Aluminium oxide or zinc oxide. F. Ethanoic acid CH3COOH is a weak acid. Number 1, complete the dot and cross diagram in figure 4.1 of a molecule of ethanoic acid. Here they have shown the key for both the carbon atoms as well as oxygen. I'm only going to show the key for hydrogen atom. I'm using blank dot for each hydrogen. And you can see hydrogen have only 1 electrons. Its proton number is 1. It has only 1 valence electron. What about carbon and oxygen? Carbon, here it is carbon, it belongs to group 4. It has 4 valence electrons. Oxygen, it belongs to group 6. It has 6 valence electrons. So for hydrogen only, we have to place 1 valence electron for each hydrogen atom. Here 1 electron for this hydrogen, 1 for this hydrogen, 1 for this hydrogen, 1 for this hydrogen. What about carbon? It contains 4 valence electron. For the carbon on the left hand side, 1, 2, 3, 4. For the carbon on the right hand side, 1, 2. Now the last 2 electrons will form a bond with the oxygen on the right hand side because it's a double covalent bond. So you'll have 2 valence electrons placed here. What about oxygen? Oxygen have 6 valence electrons. So 2 electrons are already shown for the oxygen atom which is attached to hydrogen. 1, 2, 3, 4, 5, Q4-6. Now the oxygen which is attached to carbon, two of the valence electrons will be shared with the carbon. 1, 2, 3, 4, 5, 6. So this will be the final dot and cross diagram for ethanoic acid. Number 2, suggest the pH of dilute ethanoic acid. Ethanoic acid is a weak acid. So the pH must be between 3 and 7. Number 3, complete the symbol equation to show the dissociation of ethanoic acid. As I've just told you, it's a weak acid, so we'll show the reversible sign for the dissociation of ethanoic acid. This is a formula of ethanoic acid. This is a sign for dissociation, and it will dissociate incompletely, forming CH3, C-double-O negative and H positive ion plus H positive ion. Number 4, write the ionic equation for the reaction when an acid neutralizes a soluble base. Soluble base means alkali. So whenever acid neutralizes a soluble base, H positive ion from the acid and OH negative ion from the soluble base reacts to form water. So the ionic equation will be H positive plus OH negative gives H2O. Moving to next question. G, in a titration 25 centimeter cube of 0.08 mole per dm cube aqueous potassium hydroxide KOH aqueous is neutralized by 20 centimeter cube of dilute sulfuric acid H2SO4 aqueous. This is a reaction equation. 2 KOH aqueous plus H2SO4 aqueous gives 8 K2SO4 aqueous plus 2 H2O liquid. Calculate the concentration of H2SO4 in gram per decimeter cube using the following steps. Calculate the number of moles of KOH used. So you need to calculate the number of moles of KOH used. Here the information is 25 centimeter cube of 0.08 mole per dm cube of aqueous potassium hydroxide. So first of all, I will convert this into centimeter cube. You know the relationship for dm cube and centimeter cube. 1 dm cube contains 1000 centimeter cube. So I will write 1000 centimeter cube contains 0.08 moles of KOH. Therefore, 25 centimeter cube contains X moles of KOH. So 0.08 multiply by 25 divided by 1000 will get 0.002 mole. Determine the number of moles of H2SO4 which react with the KOH. Now we need to calculate the number of moles of H2SO4 which is reacting with KOH. Here's the relationship. So 1 mole of H2SO4 react with 2 moles of KOH. Therefore, X mole of H2SO4 react with 0.002 moles of KOH. Do the cross in order to find the value of X. We will get 2X is equal to 0.002 or X is equal to 0.002 divided by 2. What we will get? 0.002 divided by 2. 0.001 moles of H2SO4. Now calculate the concentration of H2SO4 in mole per dm cube. Coming back to the question again, you can see 20 centimeter cube of sulfuric acid is used here. So these are the moles in 20 centimeter cube. So what you will write? 20 centimeter cube contains 0.001 mole. Therefore, 1000 centimeter cube contain X mole. So we will have X is equal to 0.001 divided by 20. 0.001 divided by 20. You will get, so we need to multiply 0.001 by 1000 also. I need to write it again. 0.001 multiplied by 1000 divided by 20. 0.001 multiplied by 1000 and now it's divided by 20. 0.05 mole per dm cube. Next part, calculate the concentration of H2SO4 in gram per dm cube. For this, we need to calculate the MR of H2SO4. MR of H2SO4. We have two atoms of hydrogen. Two will be multiplied by, here is hydrogen. One is the mass number of hydrogen. What about sulfur? Here is sulfur. The mass number is 32. Oxygen. Here is oxygen. Mass number is 16. So 2 multiplied by 1 plus 1 multiplied by 32 plus 4 multiplied by 16. So we'll get 2 plus 32 plus 64. So we will get what? We will get 98. So in order to get the mass, we need to calculate the moles into MR. So moles is 0.05 and it will be multiplied by MR, 98. 0.05 multiplied by 98. 4.9 gram per decimeter cube. Moving to next question. Number 5, propane and propene both react with chlorine. A. When a molecule of a propane C3H8 reacts with chlorine in the presence of ultraviolet light, one atom of hydrogen is replaced by one atom of chlorine. Number 1, state the term given to a reactions in which one atom in an alkane is replaced by another atom. These are substitution reactions. So you write substitution. Number 2, state the purpose of ultraviolet light. It's providing activation energy. Provide activation energy. Number 3, state the term given to any reaction in which requires ultraviolet light. We call it photochemical reaction. The reaction catalyzed by light, photochemical reaction. Number 4, write the symbol equation for the reaction between propane and chlorine. This is a formula for propane, C3H8, chlorine. It belongs to group 7. Here we have chlorine. They all exist in diatomic state. So you'll write plus 32. One of the atom, that is hydrogen, will be replaced by chlorine. So you'll write C3H7Cl and plus HCl. So these are the two products obtained in this reaction. B. A molecule of propene C3H6 is unsaturated and will react with chlorine at room temperature. Number 1, state why propene is an unsaturated molecule. It contains carbon-carbon double bond. It contains carbon-carbon double bond. Or you can even write it has a carbon-carbon bond which is not a single bond. which is not a single bond. Number 2, give the structure formula of the product of this reaction. So we need to draw the structure formula of the product of this reaction. This is an addition reaction. You simply have to add chlorine molecule to propene. So in order to draw the structure formula, how many carbon atoms are there? There are 3 carbon atoms. You need to show the condensed formula. The formula will be like this: CH3, CHCl. You have to add chlorine atom to do 2 different carbon atoms. Chlorine molecule will not attach to single carbon atom. It will go to 2 different carbon atoms, especially those that having double bond, adjacent double bonds. CHCl, and we will get CH2Cl. This will be the final formula. Number C, propene undergoes addition reactions with steam. There are 2 possible products, A and B. Draw the displayed formula and name each product. Displayed formula of product A. So propene is undergoing addition reaction with steam. We need to draw the displayed formula of 2 products. So I'm going to draw the displayed formula of propene first. Here we have propene 1, 2, 3. So I'm placing double bond on the right hand side. So let's saturate the bonds of carbon on the right hand side. 1, 2, 3, 4. 1 second carbon atom, 1, 2, 3, 4. Last carbon, 1, 2, 3, 4. Placing the hydrogen atoms. So this is the displayed formula of propene. Plus steam. The formula for steam is HOH. So these steam will form a bond with this propene, producing products with 2 possible structures. So either this OH will attach to this carbon, situation number 1, I will write it here, or it will attach to this carbon. This will be B. This hydrogen will definitely attach to another carbon atom at the same time, forming the addition product. The addition product is known as alcohol here. This is alcohol. We are getting alcohol, and in this case we will get propanol. Propanol. So if the OH is attaching to the first carbon, that is on the right hand side, let's call it first carbon, 1, 2, 3. We will get propane 1-ol. Name will be propane 1-ol. Displayed formula will be this: 1, 2, 3. Attaching OH. This will be the final formula for propane 1-ol. What about the displayed formula of structure B? In structure B, OH will be attached to second carbon. So we'll get propane 2-ol. Propane 2-ol. Displayed formula will be this: 1, 2, 3. This time I'm attaching OH to the second carbon. OH. It's up to you whether you can place it at the bottom or the top of this carbon. I'm saturating the carbon. So this will be the final displayed formula for propane 2-ol. Moving to next question. Number 6, carboxylic acids can be converted to esters. A. Name the ester formed when butanoic acid CH3, CH2, CH2, COOH reacts with ethanol CH3, CH2OH. So the other name for ester is also alkyl alkanoate. The alkyl group is coming from the alcohol. So here we're getting alkyl group. And in this case, we will get ethyl. And alkanoate group will be coming from the carboxylic acid, which is butanoic acid in this case. So you will get ethyl butanoate. ethyl butanoate. B. Identify the other product formed in this reaction. Water, or you can even write the formula of water, H2O. C. Deduce the empirical formula of the ester formed. So first of all, I need to draw the formula for ester, then I will draw the molecular formula, then we'll make the empirical formula of this ester. So here we are having butanoate group coming from this butanoic acid and alkyl group, that is ethyl group, coming from this ethanol. So the formula will be CH3, CH2, CH2, COO, CH2, CH3. Now I am writing the molecular formula. So how many carbon atom? 1, 2, 3, 4, 5, 6. So you'll have C6. What about hydrogen? 3, 2, 5, 5 plus 2, 7, 7 plus 2, 9, 9 plus 3, 12, H12. What about oxygen? 2 oxygen, 1, 2, O2. So the empirical formula for this ester will be C3H6O. This will be the empirical formula for the ester form. D. PET is a polyester. Part of the structure of PET is shown in figure 6.1. This figure 6.1. Number 1, circle one repeat unit of this polymer. I have to circle one repeat unit of this polymer. This will be the repeat unit of this polymer. Either you can circle this one, or this one, or this one, or this one. Any one of these. Any one of these 4 circles. Number 2, draw the structures of the monomers which make up PET. Draw the functional groups using displayed formula. So we'll go to the in reverse direction in order to draw the monomers for this PET. So for this one, what we will do, we will need to attach OH on adjacent end. So we will get this C double bond O, C double bond O, simply attach OH. This will be the one functional group. What about second functional group? This one is repeated after this one. So we'll get HO bond. So we have diol and dicarboxylic acid. This is diol and this one is dicarboxylic acid. Number 3, state the type of polymerization used in making PET. It's condensation polymerization. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.